GuidePoint. He's been in InfoSec IT for 15 plus years. And one thing about Joey, if you need somebody to do a deep dive for you, this is the guy. He's a certified dive master. Okay. So Joey's going to offensive mobile forensics. All yours.
Thanks, Tom. Thanks for joining us today. Forgive me, but I can talk for about 2 hours on this stuff, and I've got 30 minutes if I'm going to save time for questions, so I'm going to go extremely fast. I'm also going to do a live pin cracking demo for you, and based on the passcode I've selected, it should take about 28 minutes to complete that. So we're going to go ahead and get started. So my name is Joey Peloquin. I'm the Director of Professional Services at GuidePoint Security. I've been doing mobile security research for about 5 years now. I created the offensive mobile forensics methodology for 2 reasons. Number one, at the time, everybody was doing mobile application pen testing on simulators. And you cannot look for data leakage when you're pen testing on a simulator. And I wanted to show, based on my research, we absolutely have to include that in a mobile application assessment. The second reason that I did this is to quantify the risk of a person of interest losing their device. Loss or theft is the #1 risk to these devices and to BYOD in general. So we needed a way to be able to quantify risk if our CEO, CIO, somebody with access to sensitive data that's storing that sensitive data on their mobile device, loses it, they're targeted, it gets stolen, whatever the case may be. So that's what OMF is all about. I will say that I'm only going to do this talk one more time. That's at RBASec in June. I'm going to retire this because people have caught on. And now if you look at all of the automated penetration testing tools that exist for mobile, they take data leakage from the mobile top 10 very, very seriously. And it's part of everybody's assessment now. So mission accomplished. The message is out there. I'm also going to release a tool at RBASec. I wanted to release it at BSides today, but it's not ready. I'm writing a Python tool to automate the data acquisition process that I'm going to talk to you guys about today. Let's see, takeaways. So you'll be able to, there's a number of things that are included in the deck. The deck will be available for download. I've already done all the research for iOS version 4 through 7.0.6 and Android 2.3.3 through 4.2.2, and I've got research for 4.3 and 4.4 as well, but I kind of tabled that so that I could do some Knox research. So I'll get this thing updated with all of that stuff, and obviously the tool that gets released in June will have support for all of those versions, okay? I'll save some time for questions at the end. I'm going to go really fast here. Actually, let's get started with the demo. Sorry for the gentleman that's trying to take pictures here. So I'm going to do a live pin cracking demo for you guys. It is no secret that 4-digit simple passcodes are ridiculously easy to crack. There's free and open source software out there that we can use to do it. Unfortunately, iOS has broken all of that stuff, so it really only works up to 5.1.1 now. We can do some limited things with Scalpel and some other mobile forensics things on version 6 of iOS, but these tools really don't work anymore. So now we have to look at commercial tools. LCOMSoft is probably the best known commercial tool that you can use for cracking simple passcodes. There's not anything out there that I'm aware of that can crack complex passcodes on later versions of iOS. Okay, so real quickly, this is what we're going to go through. I'll make this slide deck available as well if you want it, or you can just go out to the iPhone Data Protection Wiki and get this stuff yourself. But essentially what I'm going to do is I've got an iPhone here. So the requirements for this, it has to be a jailbreakable device. We have to be able to crack the bootloader, which means iPhone 4 is the last device that you'll be able to test on. Okay, it doesn't have to be jailbroken to perform this experiment, but it does have to be jailbreakable. Okay. So what I've done is I've put a passcode on here. Normally I allow the audience to just pick a passcode so that I don't know it, but we don't really have time for that. So 9371 is the passcode that I've put on here. Okay. The reason that I chose 9371 is I know for a fact it takes a long time to crack. Okay. So here's some stats. Go ahead and have a look at that while I get this thing set up. Okay, you're not going to be able to look at that, but you can see me setting up the actual experiment here. So the first thing that I'm going to do is I'm going to use everybody knows what Red Snow is, I would imagine. It's a tool that we use for jailbreaking these devices. As you may know, with Red Snow, we can load custom images on a device. Okay, so that's what we're doing. Years back, when the kids from France cracked the keychain in the device, this is the same type of process that they used so that they could load their own image, crack the keychain on the device, and then send the secrets off the device. So the first thing I'm going to do is execute Red Snow. Red Snow is going to complain because my device is on. So I'm going to have to turn this off. I'm plugged in. Red Snow is going to detect that the device is off, and then it will let me proceed. There we go. And you're going to see the Lime Rain boot exploit go here in just a second. There we go. So I did a bunch of work up front for this. Obviously, I created a new kernel image and all that sort of thing. All the instructions are out there for you on the iPhone Data Protection Wiki if you want to do this type of experiment yourself. So the device is rebooting now. You can see the pineapple there. All right, now the rest of this is going to happen on the device. So the next thing that I'm going to do, I'm doing this over USB. So I'm just going to open up a connection, forward some ports. Now, I have two options here. I can actually crack on the device. If you look at the lower shell window there, that is the actual device. Yes, Alpine is the password because this is a test device, and it's in airplane mode anyway, so good luck hacking. And what I'm going to do is I'm actually going to crack this on the Mac, and this is going to count down. So he said enter the passcode, or if you want to brute force the passcode, just go ahead and let it go. So we're going to let that run while I'm talking. It should take roughly 28 minutes or so to actually crack. So real quickly before we get into the OMF talk itself, I wanted to share some of these statistics real quickly with you guys. Hopefully you got a chance to look at this. This tells you the cracking time for the passcodes. So there's a bunch of different documentation out there. I've put some links and things in here. Again, I'll make this slide deck available for you guys. Again, LCOMSoft is the commercial tool generally that people are using. There's various commercial forensics products as well that have varying levels of support for mobile. This is a study that's pretty interesting with 4-digit pins. I'm not going to go into it because I don't have time, but again, you can peruse the slides at your leisure. Okay? So, let's get done with that. And let's do this. So we're at 3% estimated time of cracking, 27 minutes. Here's some Google stats. I'm going to actually skip these because I like to talk about the cooler stuff more, but essentially, we don't need these statistics to tell us that mobile is here to stay, right? BYOD is here to stay. Everybody's dealing with threats of mobile devices in their environments. They're looking at mobile device management solutions, mobile application management solutions, mobile information management solutions. The problem with MDM, MAM, MIM, etc. So this is kind of an evolution that has occurred. You know, we've been saying for years, the end result is we need to protect our data. So all of these things, these inefficient, not quite there technologies and point solutions like MDM was an attempt to protect our data. Unfortunately, they pretty much fail. So MAM is the closest that we can get to protecting our data today because we can apply specific policies to each application. We can do per application VPN tunnels and some other really cool stuff. The next wave is a bunch of vendors that are in stealth today. They're making point of origin encryption solutions where you can encrypt data that you create in your browser. You can encrypt data that you create in Microsoft Office, for example, and then the encryption follows the document wherever it goes. And you can put custom policies on it that says, hey, anybody can open this for 6 hours, after that, nobody. Or anybody can rewrite this for 6 hours, after that, only read. It's unlimited as far as the policies that you can do. So some of the tools. Offensive mobile forensics is about using hacker tools and techniques to explore these devices, determine exactly what data is out there, what kind of data leakage is possible in the event of loss or theft of the device. So these are some of the commercial tools that are available for forensics. We've got Encase and SQLite up here, which are the two of the most popular ones. If you're here to learn about Encase and SQLite, you're in the wrong talk because we're not going to talk about those. We're going to talk about hacker tools. This is a list of some of the tools that we use. We don't necessarily use all of these for every engagement or every assessment of the device or every experiment, but there's a bunch of different things in here. Obviously, you can do most of this stuff on command line. After you have analyzed thousands of applications, command line gets particularly painful, especially when we're talking about SQLite, shell commands, and that type of thing. So I like to work smarter, not harder, so I went out and found GUI applications as well for large-scale assessment that I can use. So I've got our browser that I use for SFTP to the devices so that I can pull information over. In the Python program that I'm writing, I'm using SCP, thank you David Bressler, to pull that stuff over. And then I use Base as my favorite SQLite client. It actually has the capability to read blobs. I used to use Razor SQL for that. It doesn't really interpret blobs very well. And unfortunately, since iOS 6, most of the interesting stuff is stored in blobs. So you're going to have to be able to get in there to actually see what's up. Some of the tools, obviously we have to jailbreak the device. That is a requirement and will continue to be a requirement. There is no public jailbreak available for 7.1. And I will go on record as saying there will not be, okay? Because these guys are looking ahead to iOS 8, and there's no way they're going to burn any exploits on 7.1 when iOS 8 is around, okay? This is very, I don't know, this caused a lot of political stuff in the jailbreaking community. Essentially, WinOCM is a very famous guy. He's been working on jailbreaks. He burned an exploit for 6.16 that was a major exploit, and then he found what he thought was another boot ROM exploit for 8.5 devices. He has declined to share that with anybody, including, bless you, the rest of the jailbreak community. So it remains to be seen if WinOCM is actually going to share this and make it possible for us to be able to jailbreak and do the kind of analysis on these devices that we need to. I think jailbreaking should be allowed because it keeps Apple honest. It provides for checks and balances. Look at the fact that we just found out since iOS 7 came out, email attachments are not encrypted, for example. How are we going to know that if we don't have researchers that have root access to these devices that can keep those guys honest, right? So it's an important thing. Lots of tools out there. iPhone Explorer is a pretty cool tool. It enables you to explore your file system on your device. You do not have to be jailbroken. Phone View is another interesting tool. I've done forensic reviews of applications where they don't allow those applications to be installed on a jailbroken device. If you look here, this is at an application level, this is where all the really interesting stuff is. So the SQLite databases where data is being stored, you'll find those typically in the library here. In preferences, you'll find plist files that are like INI files in the old Windows days. They're config files. You'll find credentials stored in there very commonly. Under caches is typically where you'll find your SQLite databases that contain the information for the application. There's some really weird stuff going on. We've been doing some mobile app assessments at GuidePoint on phone gap applications that are written in HTML5, CSS3, and JS so that they're cross-platform. They develop it once and then distribute to many different platforms. I find those to be really insecure. For example, an app we just finished an assessment of, it stored, we were able to figure out which encryption library they were using from local storage because they were storing all of their responses to local storage. We found their IV, we found their key, we found their salt, and we found the ciphertext and the password that was used to encrypt it, all in local storage. So if you're developing HTML5 mobile applications, definitely be aware of storing stuff in local storage. Devs, when we talked to the devs, they had no clue that was happening. So it was the framework that put that stuff in there. So what we're looking at right here, this is our browser. It's a GUI SFTP client. What I'm telling you here is pull that stuff over to your host computer because you can do much quicker analysis there. You can certainly do analysis on the mobile device itself using the SQLite 3 client, etc. But again, it's very painful. Trust me, I've been doing this for 5 years, and it's better to work smarter, not harder. So Android, there's a bunch of different tools that we use for Android. Same principle, although you don't need to put OpenSSH on the device because we can use the Android debug bridge to get remote access. And then obviously we've rooted that device so we can ask you to root. And then we have unfettered access to the file system. I had one incident where Android debug bridge I don't know what happened, it just exploded, it wouldn't work, I couldn't get remote access to the device. So what I do with my Android devices now is I go ahead and put OpenSSHD on there. There's a cool SSH server that's available in Play that you can do. So what we're looking at right here, this is ADB, tells me the devices. I've SU'd the root, I can see all the file system. DumpSys is a debug utility that's provided with Android, which has ridiculous amount of data leakage. Developers have to be really careful about debug information on the Android platform. What we can see right here is I've got my account names for a couple of accounts. We can see I used to have an Exchange account on here, but I removed it, but there's still remnants of it. That's something that's very critical for you guys to take away from this. Just because you delete something on your mobile phone, don't think that it's gone forever. Particularly iPhone users, you'll fill up your voicemail and then you have to delete them. Do you think they really get deleted? Nope. So I've been using the same device for about 2 years now. My keyboard cache is 18 months old. My keyboard cache on that device is not rolled for 18 months. So there's 18 months worth of key logged data in that. And I'll talk a little bit about that later. So these are a couple of tools. This one, I wanted to put this up here because it's really cool. Samsung, screw you, I'm done with you. I used to do all of my research on Samsung devices. Knox has killed that, okay? So I don't like Samsung anymore. Now I like the Nexus devices. There's this really cool Nexus Route Kit right here that we can use that makes rooting, I mean, a 2-year-old could root a Google Nexus device. So I really like it. This is Quick SSHD, the backdoor that I typically put on my Android devices. And then this is the sexy GUI for Android debug bridge that I absolutely love, love, love. And David won't use it because he's a command line guy. Here's a bunch of other tools that we use. Root checker, obviously we have to make sure that we have root. You're going to need a file system browser of some type. There's a bunch of them out there. I like iExplorer, and there's one other that I like that I can't remember the name of it. You're going to obviously need a custom recovery on there if you want to load ROMs and things of that nature. Generally, I usually keep the stock image on the device and I just root it because I'm interested in what the vendors are doing. You know, a lot of modders they can't wait to get cyanogen on there. I want to see what Samsung and Google and Asus and all these cats are doing with our data. So I like to leave it stock so I can wire it up to Mallory and look at the traffic and see what kind of information is getting sent off to, the manufacturers of our phones. Okay. So again, I've already done all the research for you, and I've mapped out all the physical locations of all the interesting data on these devices. Okay, this will be all built into the tool that I'm going to release in June, but obviously it's here as well in the deck, so you can use that if you want to play in your own lab and do some experimentation of your own. And as you can see, I've covered every major iOS version since 4. So let's look at some findings. This is the keyboard cache. I like to call this Apple's native keylog facility. So the keyboard cache is actually a function of autocorrect. So everything that you type that is not a numeric digit or in a secure field, that is a field that's marked secure, gets logged to your keyboard cache on your device. You can reset this if you go into General Settings, Reset, and then there's a place down there where you can reset it. As you can see, you can take the words out of there and formulate complete sentences. So these are complete sentences from a risk assessment that I did quite some time ago, but it tells the story perfectly. Amit will coordinate that through help desk. Just need to make sure that case available. Imagine if this had sensitive information in it, right? Complete sensitive information. You could be talking, maybe it's an HR person talking about, some kind of performance stuff or disciplinary stuff. It could be financial stuff in here. I've uncovered financial information in here. I've uncovered, deals that salespeople were working on and all kinds of interesting things. Snapshots. So snapshots are a little piece of data leakage that people, didn't take seriously for a long time. But essentially what happens here is when the iPhone, when you hit the home button and you close an application, they take a screenshot so that they can do that animation. So every single application on here, when you hit the home key, takes a snapshot of that. There's a big snapshots directory that has all of them. And then you'll find this also in each application's directory, okay, on the device. Let's see, this is, I've done a number of application assessments. Many people have heard me say before, I don't install a mobile application on my device and use it until I've performed an assessment of it. Obviously, I don't look at the back end because I'm not authorized to perform a pen test. But if I find that that application is storing my data locally and it is not encrypted, then I don't use that application. And typically I will go on to Play or the App Store and I'll leave a nice nasty comment for the developer about storing my information in the clear so that everybody else can see it. This was an application that was for expense management. It's wired up to multiple cloud APIs, including Evernote, Google Docs, a bunch of others. You can fax and do all this other stuff. So here's my Evernote password stored in the clear, my username, and obviously I reject, that's my personal Gmail stuff, so I redacted all of that. Social applications are absolutely terrible chat applications. They used to be. Now I've done assessments on all of these applications again and they fixed all the problems. Typically I will alert the developer when there's an issue and I don't generally disclose details publicly. I will shame them in the Play Store or in the App Store, but then I'll send them an email and say, hey guy, you know, here's what you're doing wrong, this is how you fix it. You can use SQL cipher to encrypt your SQLite databases, etc. Chat social applications, just some more examples, all in the clear. Contacts, address book, all in the clear. The really disturbing thing about this is virtually any application can gain access to your address book. You just have to give it permission, right? Mail. Mail is something that is really disturbing on these devices, particularly on Android devices where we can find not just your creds, but all of your messages stored in the clear on the device. Every single one of them. And it's gotten worse with iOS now that iCloud is out. So they actually have two different places where they store it. They store it locally in an SQLite database that's called envelope space index, but they also have mobile mail, mobile notes, and mobile calendar where they replicate all your other stuff. And yeah, so this is actually a screenshot of some of that. So this is from mobile mail. So you can see it stores the entire message, okay? The thing that really shocked me though is this right here. So I started really kind of digging in here and looking. You can see the protected index. As we know now, the researcher disclosed that's not really protected, it's not encrypted anymore. And this is what we want to look at. So Exchange ActiveSync, the way that iOS is replicating information is it's taking stuff that's stored in the local file system and then it's putting it in a spot here that's dynamic, so it changes over time. This is the disturbing thing. So this is off my production device that I use, it's my daily driver. And you can see if somebody stole my device, where is it? This would probably be an interesting customers. Can you see that? So there you can get my entire customer list if you're able to steal my device or break into it or whatever. Demo time. All right, how we doing on the crack? Haven't cracked it yet, I don't think. No, haven't cracked it yet. Okay. So listen to this demo real quick. This is a voicemail that I recovered off my own phone.
Hi, this message is for Mr. Joseph Peloquin. This is Natasha with American General. Now, I was calling in regards to your account. Looking at it, looks like we could possibly do some cash out if that's something that you would possibly be interested in.
Yeah, so financial conversation. All of the voicemails I've ever had on this device are stored in there. You can see them by date range. And they're stored in the clear in an SQLite database right here. So the AMR files right there, those are your voicemails. And then there's a separate table that shows the caller. So who was actually calling and left the message. You know, you put all of that stuff together with the contacts that you can get off the device, etc., and you can really put a huge profile together for a person of interest that, you know, a state-sponsored attacker or a criminal attacker or somebody like that wants to target. This is com.apple.network.identification.plist. This is a configuration file that shows every single network I've ever connected to with this device. And it just continually appends to this file. And the only way that you can reset this is to do the forget the network thing in general settings. Wi-Fi. This shows all the Wi-Fi networks that I've ever connected to. And then this is a keychain. So I actually went back to Razor SQL for this on the keychain on 7.0.6 because it actually shows a little bit more information. These are blobs that show up in base. As you can see, there's quite a bit of clear text information that's still stored in the keychain. All the passwords, certificates, things of that nature are encrypted, however. The thing that's important, I've kind of talked about this a little bit, you think things are deleted, but they're really not. use strings. There's a little binary utility called strings that you can use to extract strings out of binaries. Strings is very adept at locating deleted information out of SQLite databases. And the really interesting thing is you can attempt to open a database with SQLite 3, the command line client, or Base, or some other GUI client, and it'll say, this is not a database or it's encrypted, right? Well, that doesn't stop me. You just run strings against it, and you can recover not just the deleted information out of the database, but the other information that is also not encrypted. So don't think that you're just, crap, it's encrypted, I can't get anything out of there. Try to run strings against that. And my tool will eventually be able to do that. I'm going to focus, it's going to be released in phases. First phase is just acquisition, and then I'll build a GUI and put some analysis stuff in there as well. Passbook, this is something that came along. Does anybody use Passbook to hold your train tickets, airplane tickets? Yep, me too. And there it is, there's the flight that I was on. If anybody's interested, here's the cloud URL where your information is stored. Ubiquity Assistant, this is interesting. So this is Siri. I love to use Siri to set reminders because I'm constantly, I'll be driving and I'll remember something. So I'll use Siri to set reminders. Well, little did I know that gets recorded in an SQLite database in the clear. And then goes over the wire. And here you can see these are all the Ubiquity things that have been going on the device that could potentially be interesting, maybe, maybe not. Android, same thing. Start out with Gingerbread on here, and then we go up to Jellybean for all of the interesting locations. Android has really a couple of super critical findings. Everything else is just kind of blah. But there's a couple of really gnarly things. Seriously? Already? Man. So we can get all the accounts that are on the device. We can get all the bookmarks from the browser. And obviously cache and all that kind of thing. So we can see what people have been browsing. We can get all browser data. If you notice here, form data. Okay, so it gets stored. Anybody use basic authentication? Probably. Passwords? Maybe that's interesting too, yeah? So we need to be really careful about developing mobile applications, obviously. This is the web cache. Now, this is one of the super nasty findings that I just absolutely hate about Android and why I never recommend anybody use Android in an enterprise environment. This is emailprovider.db. It's an SQLite database, stores all of these accounts in the clear, and as you can see, it's my username and my password. For my Google accounts, for my enterprise exchange accounts, etc. This is still the case. I did go verify this. This is the first thing I do when a new version of Android comes out. Google is not using their own keychain. So we've had a keychain since version 4 came out. They're not using it. They're still storing this stuff in an SQLite database in the clear. Okay? So bear that in mind if you allow BYOD Android devices in your environment. It's really easy to find this. Here you can see me using strings against it. I knew what my password is, so I just passed that to grep and said, show me that information. Boom. Pretty nasty stuff. So I don't even have to have really any skill. I just use strings pointed at the database, and I have data leak. This is mail. So Android goes a step further and logically groups all this stuff. You'll find that this is in multiple databases on the iPhone or on iOS. Google Android is excellent in terms of data leakage, and they put everything all in one space, including all of your email messages, the recipients. Well, you can see this is pretty much all of your mail on Android. Contacts, same thing as with iOS. Here's the second critical finding. Wi-Fi configuration. This is an XML file. On Android, they use XML files for config. They use plist on iOS. And as you can see, all the SSIDs that I've connected to with the pre-shared key, conveniently located in clear text. Applications. I've done a number of application assessments over the years, both official and just for my own use. Egregious data leakage. Email is considered PII if you match it with some other bits of information. It depends on what your definition of PII is. Android, don't expect your email ever to be hidden. If you're using an email for maybe anonymity purposes or something like that, if it's found on your device with the email that you use all the time, you've now blown your anonymity. Okay. Facebook creds. This is from an application that I did an assessment for. They were integrated with Facebook, so they could say, here, touch this button, and go do this. So any applications that say, games are really bad about this. They want you to post all of the stuff that you're doing on the games. 9 times out of 10, they store your information in clear, in an SQLite database. 90% of the time. What do we do? Well, I'm scared too, which is why I analyze all the applications that I use on my mobile devices. So we need to be very diligent. Some things that we need to do inside, we need to prepare appropriately, okay? Just run around with Exchange ActiveSync and saying, yeah, we've got MDM. Exchange ActiveSync is not MDM. It is the absolute bare minimum that you have, the ability to lock, wipe, and set pin complexity on a device. As we're going to see, you should not allow 4-digit pins in your environment, okay? 6 digits at least. 6 digits will increase complexity to several hours, potentially days, depending on the pin. Personally, myself, I've gone to using words. I don't even use numbers, okay? And what's better is if you can create a long sentence type of thing. Yeah?
Do GPU cracking when you do the pins?
Am I using a GPU? No, because I use LCOM-soft if I'm doing it commercially for a client, and otherwise I'm using this on much older versions. Yeah, but that's a great point. So that's actually where this kind of headed, and how LCOM did their stuff is using GPU clusters. And certainly, to his point, you can speed up the cracking process by putting a GPU cluster together. So what do? Mobile security education. It's not enough to just have mobile security awareness. We need to explain why we don't allow jailbroken and rooted devices in our environment, okay? We need to explain why we only support these versions of the firmware. We need to explain to our user community why we only allow these devices, etc. Educate them. Don't just say this is the way it is and lay down the law, because they're not going to appreciate that, and they're going to attempt to circumvent your controls, okay? So if you educate them, then you'll find that they'll be much more willing to jump on board with you. So basically, until the stealth providers come out with point of origin encryption, some of these guys are starting to come out now, but they're focused on Salesforce or something else. Until that happens, MDM, MAM, MIM, these are our, this is what we can do to help protect ourselves. Also, do this experimentation. Find out what the risk is of loss or theft of a device in your environment. And if you're developing mobile applications, please develop them securely. Look at OWASP has come a long way in the last couple of years as far as guidance around secure mobile application development, application assessment, stuff like that. So definitely visit our friends at OWASP for that information. So I was going to share some Knox stuff with you. Let's see where we are with the cracking. Still haven't cracked. Hopefully that gets done before I get booted. 4 minutes left on the crack, but I have roughly 8, I think. Okay, so I'll share a little bit of stuff with Knox. I hate Knox because I can no longer customize my phones. So essentially what Knox is it is a secured bootloader. So what will happen is this thing, it looks for custom signed code. So if you root a device, depending on the device and depending on how you root it, you could trip the Knox counter. So if you go 0 by 1, and then you attempt to go in and get service on that device, they will most likely deny you. According to some people that have posted in XDA, they've been able to go from service center to service center and eventually find a nice little hacker kid that will reset their device for them. We do know for a fact it is not in hardware. We used to think that this was in hardware, that this protection lived there. It's not. It's in software. That's been confirmed because if you take this to a service center, and you can get somebody to actually reset your phone for you, they can reset the timer on this. So this is believed to be an eFuse now, which means we can come up with a software workaround to avoid tripping it, but that research is still underway. You cannot remove Knox, you cannot completely remove it, however you can disable it, okay? And if you're still playing with Samsung devices, Chainfire actually has Super SU out that will disable this for you when you go about rooting your device. So it is looking at kernels and recoveries, looking at the signatures of those, and it will not allow custom recoveries and custom kernels to run. So what the hell is Knox anyway? Well, what it is dual persona. It's container-based solution at the hardware level. And it's utilizing the trust zone that's in Android itself. If you want to check out something that's really cool, Pike OS, P-I-K-E-O-S. These guys built a hypervisor within Trust Zone. It's really cool. They built it for like governments and things of that nature. Unfortunately, I don't know that our government is going to use it because they're Germans. And I don't think that they're allowed to use, at least some portions of the government are not allowed to use anything that's not from the United States. Okay, it's still working on it, so I'm going to keep talking here. Knox 2.0 was just released. This is actually pretty cool from the aspect of getting Android in the enterprise because it's extremely insecure at this point, as you can see. I don't recommend it. About the only way that I would recommend adopting Android in the enterprise environment is if you have all Knox 2.0 devices, which means everybody's stuck with Samsung S5s. Okay, there's no Knox 2.0. I don't think it works on any of the others. Right now there's the Note, and there's a couple of other devices that Knox 1.0. Let me finish here and then I'll take that. They came out with a couple of other things. So they renamed the Knox, the actual container, to Workspace. They now have enterprise mobility management. They can manage actually multiple types of devices, not just Samsung devices. You can manage iOS devices, etc. It's your typical MDM type solution. They have their own marketplace, and they have an SDK where you can customize it. So if you want to use these for like maybe a kiosk type of application, something like that, or maybe check in like valets and stuff like that, you can customize the device so that they can only gain access to certain pieces, certain applications, store data, obviously only in the container, etc. This is what the EMM policy list looks like. As you can see, the checks means it's supported now. The clock means it's coming eventually. Sweet. Let's see. So there we go. Can you guys see that? 9371. So here's all the cracking right here. We brute force the system key bag. 9371 is the passcode key. We've recovered all of the keys, so we have access to all of the data. And we could do a lot of other stuff now. We could download the keychain, decrypt all of that information because we now have the keys. We own this device. So nothing is now protected on this device. The good news is over 95% of iOS users upgrade to the latest version of iOS within a week of its release. So there's practically nobody except researchers running around with 5.1.1. So thankfully, this is more of a theoretical attack now. It's not really practical in the real world. Questions?
Has anybody come up with whole disk encryption for phones?
Yeah, Moxie. Whisper Systems did. But if I remember correctly, you have to root the device and do a bunch of other, it has a bunch of requirements to be able to do that. This Knox thing, I think we're getting away from full disk encryption because of the personal data, corporate data argument. There's a lot of people that have not rolled out any kind of MDM or anything because of privacy concerns, for example. I'm talking to a customer right now that's really kind of, they're getting pushback from even IT who's saying, man, this is a privacy nightmare. You're able to locate people, you're able to, change their PIN and do all this other kind of stuff. So really, dual persona is kind of where we're headed as far as this is concerned. If you look at the market, all of the vanilla MDM providers like Mobile Iron, AirWatch, etc., they're now in the MAM business. And that's because the container is the way to go. You look at Blue Box, all of those guys, they're all coming out with containers because that's the only way to really address the data protection issue and the issue of users saying, I don't want you to have control of my device. I spent $600 on this. I should be able to do whatever I want. Which we should be behind. I'm with that too. I could give a damn about your device. All I care about is my corporate data, right? Other questions?
As far as you know, is there any way to load custom kernel on Knox?
No, not today. Yes and no. Not a custom kernel. You can put a custom ROM on there with a couple of different devices. So SafeRoute is what you want to look at for the Samsung devices. And there is, what's it called? SafeStrap, I think. It's essentially a wrapper, so it's not the same. And there's a very limited number of ROMs to choose from.
If you want to enable, let's say, OTG cable or external network device, you cannot do that.
No, not on one of these devices. Yeah. you're not low level enough because you're not in Chrome. Other questions?
So when you enable encryption on an Android device, do you find that's helping you prevent against accessing the local storage, or is that just a speed bump?
It's a speed bump. Yeah. No, it doesn't do any more. I mean, once I've got root on the device, it's game over.
Anybody else? All right, remember this is session ID 13. Joey, thank you so very much.
Thanks, Tom. Thank you very much.